Another learning day, everyone. It's me again, your teacher, Marlene Nuno, and today our discussion is about the application of the trigonometric function. So we have to solve problems involving angle of elevation and angle of depression. Are you ready? So let us have the process of solving problems involving angle of elevation and angle of depression. So the first example will be discussed in a detailed process. For our example number 1, the problem is, at a point on the ground 150 feet from the foot of the flagpole, the angle of elevation to the top of the pole is 32 degrees. Find the height of the pole. Now, using this first problem, I'm going to show you the step-by-step process of solving the problem. So for step 1, let us illustrate the given problem. So this is the illustration. So we have here 150 feet from the foot of the flagpole. So this is the starting point. And we have here 150 feet from the foot of the flagpole. And then we have 32 degrees. This is the angle of elevation to the top of the flagpole. And we are asked to find the height of the flagpole. So here, this is the unknown in the problem. So for step number 2, we are going to draw a triangle to fit the problem. So this is the original figure that we have, and try to look that we are having this triangle. So let us form this. Now let us have our step 3. Let us label sides from angles view. So this is our reference angle, which is 32 degrees. Then 150 feet is what we call its adjacent. Then the height of the flagpole is called its opposite. And of course, this is our hypotenuse. After the label, let us have our step 4, which is to identify the trigonometric function to be used. So try to look at the given. So we have here the reference angle, we have the opposite, and the adjacent. So looking now at our SOHCAHTOA, which will be our guide in using the trigonometric function. So obviously, we have the tangent, which is our opposite over adjacent. So let us use this function. So for step 5, let us set up our equation. So we have the tangent as opposite over adjacent. Let us have the substitution. So tangent 32 degrees is equal to the height over 150. Then for our step 6, let us solve for the variable. So in our last discussion, we have here our tangent 32 degrees is equal to h over 150. Then by cross multiplication, we will have h is equal to 150 times the value of tangent 32 degrees, which is 0.6249. So multiplying this, we will get h is approximately 93.74. Therefore, the height of the flagpole is 93.74 feet. Now let us have our example number 2. So for the problem, a 200-foot ladder leans against a wall so that the base of the ladder is 90 feet from the base of the building. So what angle does the ladder make with the ground? So let us have our figure. we have here the building and the ladder, and that is forming now an angle of elevation. So let us have our triangle. Then we have here, from the reference angle, which is theta, the adjacent side is 90 feet, and then the ladder, which is 200 feet long, represents the hypotenuse. So what are we going to use as the trigonometric function? So we have to use cosine, which is adjacent over the hypotenuse. So by substitution, cosine theta is equal to 90, which is the adjacent side, over the hypotenuse, which is 200. So simplifying 90 divided by 200 will give us 0.45. And then using your calculator, so we have shift cosine, then the value of 0.45 will give us theta is 63.26 degrees, or this is 63 degrees and 15 minutes. Therefore, the ladder makes 63.26 degrees or 63 degrees and 15 minutes from the ground. Now let us have our example number 3. A tower is 15.24 meters high. At a certain distance away from the tower, an observer determines that the angle of elevation to the top of it is 41 degrees. How far is the observer from the base of the tower? So to illustrate this, we have the tower. Okay, this is our tower, which is 15.24 meters high. Then we have the observer on this part that makes 41 degrees as angle of elevation to the top of the tower. So how far is the observer from the base of the tower? So we have to look this part. Okay. Now, this is the equivalent triangle. So let us continue. This is our obtained triangle. Let us solve using our tangent function, which is the opposite over the adjacent. By substitution, so we have tangent 41 degrees is equal to the opposite, which is 15.24, over the adjacent, which is represented as x. Then by cross multiplication, we will arrive at x times tangent 41 degrees is equal to 15.24. Then, to solve for x, we have to divide both sides by tangent 41 degrees, and then its value is 0.8693. So dividing 15.24 by the value of tangent 41 degrees will give us x is approximately 17.53. Therefore, the observer is 17.53 meters from the foot of the tower. Now let me give you our example number 4. An airplane is flying at a height of 4 kilometers above the ground. The distance along the ground from the airplane to the airport is 6 kilometers. What is the angle of depression from the airplane to the airport? So let us have here our airplane. It flies horizontally. Then the airplane is 4 kilometers above the ground. From the ground to the airport, it is 6 kilometers. Then let us have here another segment. Now observe that we have two parallel lines. And in our previous discussion, if two parallel lines are cut by the transversal, we have the alternate interior angles are congruent. So let us draw here our angle of depression. Let us put here our theta. So similarly, below, the alternate interior angle that is equivalent to the first one is located on this. So let us put another theta. So from this part, we can find our triangle. So what trigonometric function are we going to use? That is tangent theta. So which is defined as opposite over adjacent side. So by substitution, tangent theta is equivalent to 4 over 6, wherein 4 over 6 is equivalent to 0.6667. Then using your calculator, by pressing shift tangent, then the value of 0.6667, then that is equivalent to 33.69 degrees or 33 degrees and 41 minutes. Therefore, the angle of depression from the airplane to the airport is 33.69 degrees or 33 degrees and 41 minutes. Well, that's all for our lesson. I hope you learned. So let me give you this. In mathematics, you learn and apply. So whatever you learn, whatever lesson I have discussed, try to learn and apply this. But in real life, the application of what we did, we are learning. Thank you so much. God bless everyone.